Hi, in this video I will be discussing the charge tapes lab for my Physics 2212 class. In this report I will be covering three main sections. The introduction, which consists of a description of the lab, its fundamental principles, and the overall results I achieved, data and measurements, observations, and I will conclude with a GlowScript model I created to demonstrate the two charge tapes with their respective electric and gravitational forces. Introduction. This lab allowed us to observe how electrons were transferred, as well as how to calculate the charge on a piece of clear tape. This calculation was simplified by treating the tape as a point charge. The fundamental principles of this lab were Coulomb's law and Newton's second and third laws. Here's a brief overview of the results for my lab, but I will delve more into how I got these throughout the video. Before conducting the experiment, some assumptions were made in order to simplify the problem. These include ignoring air resistance on moving objects, treating the long strips of tape as point charges with all of the charge concentrated at the center, and assuming that each U-tape had approximately the same charge evenly distributed along the tape. Next, I'm going to discuss the data and measurements and how they contributed to the calculations needed for the lab. This is the data I collected and some calculations from the floating tapes experiment. When running this experiment, I conducted several trials to determine the average distance between the two strips of tape, which was approximately 0.033 meters. Then I solved for the gravitational force. I then set this value equal to the electric force so I could isolate and solve for the charge of the tape, Q, which was 1.54 times 10 to the negative 8 coulombs. Next, I calculated the number of electrons on tape B by dividing the charge of the tape that I calculated by the charge of one electron. Then, I calculated the number of atoms on the tape. I calculated the area of the tape and the area of the atom and divided these values to find the approximate number of atoms on the tape. To find the ratio of electrons to atoms, I divided the number of excess electrons by the total number of atoms on the tape. Observations. Once I had created a charged U-tape, I began observing how it interacted with different objects of different charges in order to determine the charge on the U-tape. I observed that the tape was attracted to neutral objects, such as my hand or a book. However, when the first U-tape was placed near a second U-tape, they repelled. This demonstrated that the tapes had the same charge. To determine if the charge was positive or negative, I rubbed a t-shirt on a plastic straw to give it a negative charge, and I brought the straw near the tape. The tape stuck to the straw, indicating that it was attracted to the negatively charged straw. This revealed that the U-tape was positively charged. After knowing the results of the experiment, here are some questions to consider. What if electrons had a positive charge and protons had a negative charge? In this case, nothing I observed about the interactions between the objects would change. Like charges would still repel, and opposite charges would still attract. Next, it is important to handle the tapes as little as possible so the tape remains positively charged. When the tape comes into contact with your hand, which has a neutral charge, the tape will begin to neutralize as well because it will equalize with the charge on your hand. This can cause experimental error if the tape loses its charge. Lastly, I will show you my GlowScript model so we can see how everything looks conceptually. The image on the left shows tape A and tape B as point charges. The yellow sphere represents tape A and the blue sphere represents tape B. The green arrow pointing upwards represents the electric field and the red arrow pointing downwards represents the gravitational field. I have also included the charge and number of electrons on the tape displayed at the bottom of the model. That's all for Lab 1. Thanks for watching.